Welcome to this video mini lesson introduction to confidence intervals. Confidence intervals are used to estimate a parameter, usually mean, but it could also be something like standard deviation, within a range of values. So when you're using confidence intervals, it's going to give you a lower range value and an upper range value, and the population parameter, usually mean, should fall somewhere between that lower limit and the upper limit in your range. And it's a confidence interval is given within a certain degree of certainty. Usually you use a 0.95 confidence interval, which represents the probability that the actual parameter, usually mean, will fall within your range of values. So that would be a 95% chance that your parameter of mean would fall within your range. But you can also use a 0.99 probability confidence interval, which means that your mean has a 99% chance of falling somewhere within your range. So confidence interval is going to be a range with a lower value or lower range limit and an upper range limit. So let's compare confidence intervals to point estimates, because we've just been doing point estimates with our t-test. And a point estimate answers the question, is our sample from the population, or does it fall within one of these exclusion areas, which would mean that the sample is statistically significantly different from the mean, from the population mean. But when we talk about confidence intervals, we're actually answering a different question. When we talk about confidence intervals, we're actually focused on the inclusion area as opposed to the exclusion areas. And confidence interval addresses the question of within what range does the population parameter, usually mean, fall. So let's look at how we would calculate this. The formula for calculating confidence intervals is very similar to the formula that we use to transform a z-score into a raw score. So hopefully you remember this, where x, the raw score, is equal to your z-score times the standard deviation of the population plus the population mean. So this is quite analogous when we're transforming from a t-value to a confidence interval. Here, the confidence interval is equal to plus and minus. Remember, we have to do plus and minus because we're looking for a range. The t-value times the estimated standard error of the mean plus the estimated population mean. So this is the formula that we use to calculate our population mean confidence interval. And like I said before, you can calculate for a confidence interval at 0.95 or 0.99 levels. Now, if you think about it, the confidence interval at 0.95 means that your range, represented here by this very sophisticated graphic of mine, that the mean has a 95% chance of falling within that range. If you have a confidence interval of 0.99, that means you have a 99% chance that your mean will fall within that range. So this is going to be a wider range than your 0.95 confidence interval. And because this is a narrower range for your 0.95 confidence interval, it's going to be more precise than your 0.99 confidence interval, because this is going to be a wider range. So it's going to be less precise. However, your 0.99 confidence interval is going to be more certain. You have a 99% chance that your mean falls within this range, whereas when you're dealing with a 0.95 confidence interval, you're less certain because you're only 95% sure that your mean will fall within that range. So there are benefits and drawbacks to using each of these confidence intervals, and these are the two most common that you would use. So you would make your determination based on whether you're looking for more precision or you're looking for more certainty. This concludes the video mini lesson introduction to confidence intervals, and as always, please let me know if you have questions. Thank you.